Hello, everyone. Welcome to another episode of ML for Noobs. Now, yesterday when we stopped, we just reached the part of the lesson where Jeremy was going to take us through how to move an app to production. All right, so all this stuff that we've been doing in notebooks, and really the goal of today's lesson, or the rest of lesson two, is to get an app into production. So that's what we're going to be doing now. But just a little update from the last exercise we did. So we were doing a black, teddy, and grizzly classifier yesterday. And I was showing you towards the end of that practice session where we did the cleanup using the image cleaner. Now I was actually able to run the figures again after the cleanup. I never got around to doing that yesterday. And the error rate ended up being 0. It's insane. Like, we just downloaded 250 images from Google Images of each of the different classes of images, and we were able to get 100% accuracy for classifier. Take a moment to let that sink in. This is insane. Like, this is madness. I had no idea it could be this quick. Like, you're actually getting something with such high accuracy in such a short period of time. It's insane. And this is even without any of the optimizations, right? This is just pure, all right, let's just run it with our ResNet 34. And that's it. Nothing else. So anyway, that said, let's see if we can get something deployed to production. That'd be super cool. Let's see if that's something that we can do today. Take it away, Jeremy.
For productionizing things, you need to actually build a production web app, which we'll look at next. Okay, so after you have cleaned up your noisy images, you can then retrain your model, and hopefully you'll find it a little bit more accurate. One thing you might be interested to discover when you do this is it actually doesn't matter most of the time very much. On the whole, these models are pretty good at dealing with moderate amounts of noisy data. The problem would occur is if your data was not randomly noisy, but biased noisy. So I guess the main thing I'm saying is if you go through this process of cleaning up your data and you rerun your model and find it's like 0.001% better, that's normal. Okay, it's fine, but it's still a good idea just to make sure that you don't have too much noise in your data in case it is biased. So at this point, we're ready to put our model in production. And this is where I hear a lot of people ask me about, which mega Google, Facebook, highly distributed serving system they should use, and how do they use 1,000 GPUs at the same time, and whatever else. For the vast majority of things you all do, you will want to actually run in production on a CPU, not a GPU. Why is that? Because the GPU is good at doing lots of things at the same time. But unless you have a very busy website, it's pretty unlikely that you're going to have 64 images to classify at the same time to put into a batch into a GPU. And if you did, you've got to deal with all that queuing and running it all together. All of your users have to wait until the batch has got filled up and run. It's a whole lot of hassle, right? And if you want to scale that, there's another whole lot of hassle. It's much easier if you just grab one thing, throw it at a CPU to get it done, and it comes back again. So yes, it's going to take maybe 10 or 20 times longer, right? So maybe it'll take 0.2 seconds rather than 0.01 seconds. It's about the kind of times we're talking about. But it's so easy to scale, right? You can chuck it on any standard serving infrastructure. It's going to be cheap as hell. You can horizontally scale it really easily, right? So most people I know who are running apps that aren't kind of at Google scale based on deep learning are using CPUs. And the term we use is inference, right? So when you're not training a model, but you've got a trained model and you're getting to predict things, we call that inference. So that's why we say here you probably want to use CPU for inference. So at inference time, you've got your pre-trained model, you saved those weights, and how are you going to use them to create something like Simon Willison's KUKA detector? Well, first thing you're going to need to know is what were the classes that you trained with, right? You need to know not just what are they, but what was the order, okay? So you will actually need to serialize that or just type them in or in some way make sure you've got exactly the same classes that you trained with. If you don't have a GPU on your server, it will use the CPU automatically. If you want to test, if you have a GPU machine and you want to test using a CPU, you can just uncomment this line, and that tells FastAI that you want to use CPU by passing it back to PyTorch. So here's an example. We don't have a KUKA detector. We have a teddy bear detector, and my daughter Claire is about to decide whether to cuddle this friend. Okay, so what she does is she takes Daddy's deep learning model, and she gets a picture of this, and here's the picture that she's uploaded to the web app. Okay, and here's a picture of the potentially cuddlesome object. And so we're going to store that in a very important image. So open image is how you open an image in FastAI, funnily enough. Here is that list of classes that we saved earlier. And so as per usual, we created a data bunch. But this time we're not going to create a data bunch from a folder full of images. We're going to create a special kind of data bunch, which is one that's going to grab one single image at a time. So we're not actually passing it any data. The only reason we pass it a path is so that it knows where to load our model from, right? That's just the path, that's the folder that the model's going to be in. But what we do need to do is that we need to pass it the same information we trained with. So the same transforms, the same size, the same normalization. This is all stuff we'll learn more about. Just make sure it's the same stuff that you used before. And so now you've got a data bunch that actually doesn't have any data in it at all. It's just something that knows how to transform a new image in the same way that you trained with, so that you can now do inference. So you can now create a CNN with this kind of fake data bunch, and again, you would use exactly the same model that you trained with. You can now load in those saved weights, okay? And so this is the stuff that you'll do just once when your web app's starting up, okay? And it takes 0.1 of a second to run this code. And then you just go learn.predict image. And it's lucky we did that because it is not a teddy bear. This is actually a black bear. So thankfully, due to this excellent deep learning model, my daughter will avoid having a very embarrassing black bear cuddle incident. So what does this look like in production? Well, I took some Wilson's code and shamelessly stole it, made it probably a little bit worse, but basically.
Okay, hang on. Let's run that just to see what it looks like. Now, I kind of I googled some of this before, and I was actually able to test Paul Graham's photo. You'll remember that from the earlier session, and so yeah, that's that. Learn is not defined. All right, so I guess I need to run all of the statements that I'd run previously. I hope I don't have to. Oh, don't tell me I have to retrain the model. No, you're gonna load it, so you don't have to do any of this. All right, cool. So I'm not gonna download the images or do any of that. All I need is, let's see, verify images. No, we don't need to do that. Random seed. It's for viewing data. We don't actually need that. All you need to do is load. Alright, so set up the CNN learner. Data. Alright, no. I'm just gonna load. Where do you set up learn? Learn is set up here, but it needs data. Where do we get data from? Data.classes. No, data is not defined, so we need to define data. Where do we define data? Alright, we run that. Where do we define data? Okay, come on. Where do we define data? Oh, here it is. Path is not defined. Oh my god, this is getting very, very involved. Path.ls. Name folder is not defined. That's the destination, but path is not defined. Alright, doesn't matter. So now we come here. This should work fine. Come on. If you already cleaned your data, run this one instead. Alright, I'll load that one. Doesn't matter. Alright, so data classes should be working now, and we should be able to go here and load. Where's the production stuff? Alright, putting your model into production. So let's go ahead and load after clean. Stage 1 after clean. Learn is not defined. What? Oh, I didn't run that. Let's do that. Come on in. Alright, so that's ready, and then we load stage 1 after clean, and we should finally be ready to do our alright, so this part here. Learn export works. We'll set it to CPU, and we'll open up our image. That should work fine. Alright, so we got black bear. Now we load learner path. Okay, path contains the file export.pkl from before. Apparently, so what is path? Path data / bears. Okay. I think that's under tutorials. Alright, we're here. We'll go to data, and we have spares. Just to make sure we do have this file, export.pkl. Alright, that's interesting. That's our model, apparently. Great, so now we say predict class. Alright, we got category black. Cool. So you just load the learner, you call learn.predict on the image, you're done. That's it, that's all you need. Load.learner, pass the image to predict, and you're done. I wonder what the other stuff is. So I can see pred. Alright, so pred index, that's going to be the index, right? Then outputs, what's that about? Okay, bunch of random numbers. I don't know what that is. Cool, so we're following.
It's going to look something like this. So Simon used a really cool web app toolkit called Starlet. If you've ever used Flask, this will look extremely similar, but it's kind of a more modern approach. By modern, what I really mean is that you can use a wait. It basically means that you can wait for something that takes a while, such as grabbing some data, without using a process. So for things like I want to get a prediction, or I want to load up some data, or whatever, it's really great to be able to use this modern Python 3 asynchronous stuff. So Starlet would come highly recommended for creating your web app. And so yeah, you just create a route as per usual in a web app, and in that you say this is async to ensure that it doesn't steal process while it's waiting for things. You open your image, you call .predict, and you return that response. And then you can use a whatever JavaScript client or whatever to show it. And that's it. That's basically the main contents of your web app. So give it a go, right? This week, even if you've never created a web application before, there's a lot of nice little tutorials online and kind of starter code. If in doubt, why don't you try Starlet? There's a free hosting that you can use. There's one called Python Anywhere, for example. The one that Simon's used, we'll mention it on the forum. It's something you can basically package it up as a Docker thing and shoot it off, and it'll serve it up for you. So it doesn't even need to cost you any money. And so all these classifiers that you're creating, you can turn them into web applications. So I'll be really interested to see what you're able to make of that. That'll be really fun. Okay, so let's take a break. We'll come back at 7:35. See you then. Okay, so let's move on.
Super cool.
So I mentioned that most of the time, the kind of rules of thumb I've shown you will probably work. And if you look at the Share Your Work thread, you'll find most of the time people are posting things saying.
So what I do is I want to actually try this out, just to see how it works. Starlet Web App Toolkit. Let's see if we should dive into this together, or if I can just do it on my own, and then at some point we can try to work on it together. But I'm inclined to just say, all right, you know what? Let's give it a shot right now. All right, so I'm just gonna go to projects temp, and let's see if we can just web model. Just try to do something here. So I'm gonna go with Starlet here. Also want to install an ASGI server. You know what? Never mind. I'm just going to use Flask. So I'm going to call this app.py, and then I'm going to say from Flask import Flask, and then we say app equals Flask name. And if I recall correctly, at this point you can do app.route slash and then define index, and then wherever you return would actually show up. So I just want to make sure this is working, and then you say app.start. I think it's start. Yeah, looks about right. Let's see if that works. No module named Flask. All right, let's do that. Looks good. Flask has no attribute start. Yeah, I think it's run. It's probably run. What's the deal? Exception. Debug mode on. Format error. Exec format error. Huh. From Flask, import Flask, app equals Flask, name, add app.ret, define index, return hello world, and then we run it. And looks about right. I'm not sure what else I need to do to get a Flask app running. Maybe I should use Python instead of Python 3. See if we can get that working. It's still not working. What's the deal? Oh wait, we're already using port 8080. Yeah. I need to use a different port. It's gonna make it 9000. No, that's not it. Restarting instead. What is the issue? Anyway, I'll just pause now and get it working. Alright, so after a bit of Googling, it turns out that the issue was we didn't have a shebang. Yeah. Alright, so now when I try to run this, so you can see that I just added the shebang there. Also did change mod a plus x so that this is now executable. So now when I run python 3 app.py, well, it works. And so let's see what that looks like. Alright, so we can see we have hello world. Great. So this is working like it needs to. So now what we need to do is somehow get this to work with our model. Okay, that's that's gonna be a bit tricky. So wait, hang on. Why am I doing it here? Like, why don't I just copy my app.py? So just add Flask into the notebook directly. Yeah, this is a copy anyway, right? So let me try that. Let's see if we can execute that. From Flask, import Flask. Alright, that worked. And so, and then alright, so then what we want to do is copy all of this, and app equals Flask, and let's just make sure that's working. Exception has occurred. Use TB to see the full backtrace. So you can run that again. Nope, not working. App.run port 9000. Yeah, it's not giving us a result. So maybe we should just import all of the stuff that we had done up there and try to get it to run locally. Alright, so what are the imports that we needed? Let's see. We had fast AI, so let's go pip3 install fast AI. And then we're just gonna do from fast AI dot vision, just import all of that stuff. All right, let's just wait for that. Okay, so we're done installing the FastAI package, and now we can actually manage to get this thing running. And so I'm going to show you what I've done so far. So here's the code. It's pretty much what we saw earlier, but obviously I've imported the FastAI packages. I've also imported Path, because apparently that's not available by default in Python 3.6, which is the version that I'm using. And then there's also, so I organize this a little bit. So up here is all of the inputs that we require in order to get the model working. So we're not doing any training at this point. According to Jeremy, this is called the inference stage. So anyway, all we need is these two things really. The classes, so we need to know the classes in order. And we store those in an array or a list in Python, and then also the path to the export.pkl file. So this is pretty interesting. This export.pkl file is an 87 megabyte file that I imagine just includes all of the model, the trained model. So all of that data, I guess the weights or biases or whatever it is, are all stored in this file, and you can't actually read it. It's binary, so you're not going to see anything useful. But anyway, yeah, this is what you need: the classes and the path to that file. And then once you've got that running, the rest is just Flask goodness. So you run up the app, and then you say anything that hits the root path. We're just going to do this. So we're going to open an image. We'll open whoami.jpg, and secretly I know that this is a grizzly. And so if you look at whoami, this is a bear. I just Google imaged it, and I made sure to actually pick from an image that was not in our original list. And so yeah, just go to some other website or use a different website to search. But just make sure that this image is not something that our model's already seen, because then, like, what's the point, right? Okay, and then you call learn.predict on that, and this is just from the FastAI library, and then it returns a bunch of predictions. So with that said, let's fire it up and see what this actually looks like. And so to run this, all we need to do is run Python 3 app.py. So once you do that, wait a few seconds, and yeah, it tells you things are working fine. We're launched on port 9000, and you can see the results almost instantly. That was super fast. Remember, this is using just the CPU, but we're not doing any learning. It's super quick because it's just one image, and so yeah, that was pretty cool actually. It's pretty awesome. You can see the results. Predictions are 99.6. It's 99.67% certain that this is a grizzly. Boom! Wow, that's so cool. That is insanely good. Like, it's so. And then Teddy, it's 0.3%, and then Black is 4.7 by times 10 to the power minus 5. So that's super tiny. Even though, like, visually, the difference between a grizzly and a black bear is not that huge. And so anyway, I've got another image as well, and so I wanted to test this out. And this is a different position, right? You've got a fish, you've got like a lake, and what else is going on. And this guy is furrier and browner than usual, and his mouth is open. And so it might actually be harder to tell that this guy is a grizzly too. So look at the difference between these two images. Very different. But let's run in and see what the results are going to look like. So whoami2.jpg. Let's hit refresh. I'm not sure if I need 99.67, so that hasn't changed. I probably need to restart the server. So let me do that. Alright, give that a second. This takes a bit of time to load. Alright, 99.85% certain that this bad boy is a grizzly. Wow. Like, that is insanely good. I mean, we just trained this model with like 200 something images, and it's giving us ridiculously accurate results. Wow, my mind is blown. All right, so anyway, at this point, it's just pretty straightforward. It's trivial to deploy this to something like Heroku and have like an upload function where anyone can just upload an image and it would automatically provide you with the result. And so yeah, I'm pretty happy with how this turned out. This is not difficult at all. And I'm going to publish this code. I guess you could just type this. It's just like 29 lines, including all of the imports. But I'll publish this code to GitHub as well, just so that you can take a look at it. But yeah, this is insanely good. I love it. And so with this said, this wraps up our portion of this lesson related to pushing stuff to production. Now we're going to go hit the rest of that lesson too and finish it up. So stay tuned, follow up in the next video. I'll catch you guys later. Adios.